Hi, this is Miss Schultz. So this is going to serve as two different things. This is going to serve as number one, the way you're going to input answers to this classwork. So you can do this PowerPoint or this play pause it in two different ways. Way number one would be to do the whole classwork front and back, and then look at this play pause it and use it as a place to like input your answers and see if you're correct. Way number two would be to do it totally with me. If you have a printout, that's great. If not, please definitely have a piece of paper next to you so you can reference these. But this is going to be, okay, so I said there's two purposes to this video. Hello, by the way. So purpose number one is, grading, is like inputting your answers so that I can see that you did it, okay? So whatever you input here is gonna be you having done it. So you don't need to email either me or Mr. Clark any copy of anything. This will take care of that. Way number two is, I'm here for you virtually to support you and knowing how to do this. So this is like your, teacher supporting you / explaining how to do it / explanations. So if you would have called me over for be like, oh, I didn't understand part D, when we get to D on the video, I'm going to explain it. Now I'll explain it after you've already input your own answer, but I'm going to explain it. So whatever you would have called me or Mr. Clark over for, consulted a neighbor kind of thing, then this will help you actually do it. Okay. So that being said, let's read it. And as you do the video, I encourage you to use the pause button where you need to. I actually have the answers already written out, so I might go a little bit fast since I'm not writing. So definitely use the pace that you want. Rewind the video. That's another great thing about virtual learning is you can pause the teacher and rewind. So definitely take advantage of that, all right? So be sure to pause, rewind. Okay, use those features to help you. Okay, let's get into the actual problem. So the average monthly high temperatures for the city of Boston, Massachusetts are given below. And we have this data. And we're going to model this data with sinusoidal functions. All right, so part A, find the amplitude of a sinusoidal function that models the monthly temperature. And I'm actually going to do A and B at the same time. So I'll give you a second to input what your answers for A and B are. So A is the amp, and then B is the midline. Because my process is doing the midline first and then the amplitude, but your process might be amplitude and midline, but input both of those answers, please. Okay, let's go over it. So, okay, the midline is 50. So how I get that is I find my max and my min. So August has my max and January has my min. So my max is 80 and my min is 20. So for both the amplitude and the vertical shift, I need those two numbers. Those two numbers I use for both of these. The vertical shift, there's a formula here, but I just think to myself, what's halfway between 20 and 80? And for two numbers, halfway in between, that's the median, right? But the median of two numbers is also equal to the average. So I just average the two numbers, which is add them up and divide by 2. Or you could just think in your head like, what's halfway between 20 and 80? Oh, 50. Okay, cool. So that's the formula, but I think what's like halfway between max and min, okay? This is actually the last classwork we're going to do on modeling sinusoidal functions, so I want to make sure we have it down because this is, after this, we're going to call it a day and move on. Yes. Okay, so the amplitude, so there's two different ways of thinking of it. I think if my midline is 50, I think of the amplitude as the difference between the midline and the maximum, which is 30. So basically, I think if my min is 20 and my max is 80 and my midline is 50, this distance here is 30, and that's the amplitude. Okay. So this is that in words. This is a different formula. I know Miss Stein taught it this way, so you may have done it this way yourself if you remembered from Algebra 2 with her. Max minus min over 2. Okay, let's move on to part C. And again, if you need to copy any of this over, please pause the video, okay? What is the period, and vice versa, like if I say the answers and you've gotten them correct, you can just fast forward the video, right? I think it enables you to do that. Okay, what is the period of a sinusoidal function that models the monthly temperature? So we have my input is months. So my question is, this data will repeat, okay, will be the same but in a different spot, basically. Like the outputs will be the same with different inputs every how many months? 12. So the period is 12. Okay, now oftentimes I want to find the b. The b is 2 pi over 12, which is pi over 6, okay? So I didn't have you put input and answer for that, but right. So now let's write the whole sinusoidal function that models the temperature using t equals 1 to represent January. So common misconception with this, when it says t equals 1 to represent January, that does not mean you need to use this point. This is, I mean, and this point is a special point. It's a min, so you could actually use it. It's a special point, but this is just saying like January corresponds to 1, February corresponds to 2. This is just saying that my time is measured in months, and my first month is January. That's it. You don't have to use this point. Okay, so that being said, let's see, you can use the max, you can use the min, you can use, you can't use the middle because there's nothing with exactly an output of 50. So why don't you write a function using the maximum? Okay, so if you use the max at 8, 80, okay? So I'm gonna get you started with the form. So it'll be f of t. I mean, you can use x, but I'm going to use t because the independent variable it tells us is time. That's another thing that's telling us to use t instead of x. Equals something cosine. Why cosine? Right, because I'm using my maximum, okay, of, so this a of b, t minus c plus d, okay? So the t is going to be here and the cosine is going to be here. I want you to figure out what goes in for the a, the b, the c, and the d, and find your final model, please. Yeah, go ahead. Okay, there you go. There you go. So I use the max in August. Now there's a different way to do this. I just want to show you, you do not have to copy this down, but if you wanted to use the min, that's totally fine. You could have done negative cosine because that, if you started the min, you're negative cosine, and then January. So that's where that 1 comes from. So the phase shift in modeling has to do with where your max, min, or middle occurs. Okay, I don't know if you need to write that down or not, but your phase shift in modeling problems has to do with the point you choose for your max, min, or midline. Okay, last question. According to this model, what is the average monthly temperature in February? How does this compare to the actual average? So you can use either of these. They'll get you to be the same thing. So go ahead. February is 2. So you're going to plug in 2 for t. Into either of these models, I'm going to demonstrate using the first one. You actually don't need a calculator. I'll allow you to use one. If you have a calculator, please make sure it's in radian mode. But you can totally evaluate this solo. So go ahead, plug in t is 2, and what's the average monthly temperature? Go. Okay, let's do it together. So let's see, the average monthly, so I'm going to plug in 2 for t. So I get this, yeah? Okay, so now I'm going to do 2 minus 8, which is negative 6. Pi over 6 times negative 6 is negative pi, right? Negative pi. I'm going to do it by hand, so I think negative pi is negative 180, so that's right here. I know that cosine of negative 180, so this is negative 1, 0. Cosine's x over r, which is negative 1 over 1, which is negative 1. So I know that cosine of negative pi is negative 1. There we go. So I do 30 times -1 plus 50, which is 20. All right. So 20 is the answer. And then how does that compare to the actual, oops. How does that compare to the actual data? In February, it was really 25 degrees. So 5 degrees off, but pretty close, okay? So I wrote, it's 5 degrees less than the actual average. Okay, now for F, according to your model, what's the average monthly temperature in October? So for October, instead of using T equals 2, October is the 10th month, so I'm going to substitute 10 in for T, and again, you can do it by hand or with a calculator, so go ahead. All right, let's go over it. So I put, let me show you the whole answer here. So it looks like this. 10 minus 8 is 2. Pi over 6 times 2 is pi over 3. That's 60 degrees. Cosine of 60 degrees is a half. Okay, so I get that. So it's fairly close to 57, but definitely lower. But it's not totally out of the realm of possibilities. So. Okay, all right, let's move on to the back. Okay. Here, let me do this. All right, so go ahead and can you input your answers to A and B, please? Okay, so these are the answers to A and B. So you need to use the max and the min. I think halfway between them is the midline, so it's 78, and then the difference between the midline and the max, that's how I think of it, max minus midline is 4. But there's other formulas too. Okay. C, what is the period? What is the period? Go ahead. Okay. The period is 12. Now, it didn't ask this question, but right now, I want you to tell me the B that will be input into your, oh, it does ask you. Hey, what's the B? Oh, the B is pi over 6, just like last time because the period is the same. Okay. Write a function that models the monthly temperatures. So there's multiple correct answers. Since this is multiple choice here, use the maximum point, so July, which is 81 degrees, in order to get a function something that matches. Okay, so using the max, you get this, y cosine, because I'm using the max. Okay, if you use the min, if you use the min, it'd be negative, and then it'd be minus 2 there. Okay, anyway. According to your equation, what's the average temperature in August? How does it compare to the actual given average? So at this point, if you did this on your own, but you got a different equation here that's like incorrect, I want you to redo this before inputting your answer, okay? All right, so let's go over this. So I got 81-ish degrees. So you can see me plugging in the 8. So T right here becomes 8, all right? And then you can just see how I did everything. You could just like input this whole thing into the calculator though, just like that. But I did it by hand. Whoa, it's exactly the same. In August, it says 81, and we got 81. Cool. All right. Now write a different function that models the monthly temperature. If for part E you use sine, then please use cosine and vice versa. So for part E, we all used cosine. So now I want you to please use sine. So I want you to use sine. Okay, let's go over this. There's actually 2 possibilities, but so if I use sine, I'm going to use my midline here, okay? Sine, because why? Because sine starts at its midline. Okay, so the midline is in May, and then it goes up from May just like sine does, because sine actually starts at its midline and goes up, right? So 78 to 79 to 81 is going up. So here we go. So my model, I'm going to use 5, because this is May at midline. And then I use sine, and I made it positive because it's going up. just as an FYI, you could have also chosen November and done -4 sine pi over 6 parentheses t minus November's 11 plus 78. That would have worked as well. Because in November, you're going down. Oh, wait, 78 is not even the midline. 77 is not even the midline. Well, it'd be close. You couldn't do that. Because 78 is not the midline. Oh, okay. So according to your model from part G, so I just want to do the same exact thing, but with my different model to prove if, how my different models, I don't know, I just want to see what happens, you know? What if I plug in to this model? So plug in 8 now to this model. And if you didn't get this model when you were doing it on your own, please redo it. Okay, here is my work. And there we go. So the different models are different, but they're both really close. I mean, they're like 0.5 off from each other. So this is 1 degree higher, but it's still very close. Okay, thank you. That's me signing off. I hope you're all healthy, well, abiding by all the rules, etc., etc. Thanks. Bye.